Hello students, welcome to Ant's classes. Let's do Algebra Fundamental Concepts exercise 12A. Question 1 says separate the constants and the variables from each of the following. Now what are constants? In algebra children we come across two types of symbols. One is called the constants and the other is called the variable. Okay. Now what is a constant? It is a fixed number. And this number, the value of that number will never change. Like look at 6. Wherever you put 6, the value of 6 will remain the same. So such numbers are called constants. And what is a variable? A variable is a symbol whose value will keep changing. That is all the letters. Sometimes I can say y is 1. Another time I can say y is 2. Another time it can be 3 or 4. So the value of y or these letters will keep changing. So they are called variables. So a number by itself is called a constant. A letter by itself is called a variable. And a number and a letter together is also a variable. So here this question says separate the constants and the variables from each of the following. So from these let's pick out the constants and the variables. So the constants are 6, 5 by 4 and 0. So we have 6 here. 4y, because of the letter y, it's a variable. Because of the letter x, minus 3x is a variable. 5 by 4 is a constant. So we have to write it down. Now 4 by 5, if the number was by itself, we could have called it a constant. But when it comes along with letters, the whole thing is called a variable. Now AZ is a variable. 7p, 7 is a constant, but when it comes along with a letter, it becomes a variable. So the other constant is only 0. So we have 3 constants here and the rest are all variables. So what are all the variables? 4y minus 3x, 4 by 5 xy, az, 7p, 9x by y and 3 by 4x and minus xz by 3y. So whenever you have a letter, it is a variable. Keep that in mind. Numbers by itself, they are constants. Question 2. Group the like terms together. Now what are terms? Terms can be a number by itself or a letter, or it can be a product of a number and a letter, that is when you multiply, or it can be a quotient like this. It can be division of a constant and a variable. Now what are like terms? Like terms are terms that have the same literal coefficient, the letters, the variables. Now here there is x. I have to look out for another term which has x. Now minus x, 2 by 3x. So whichever has x, those are like terms. So I have 4x, minus x and 2 by 3x. So that will be one set of like terms. So let's write down one set first. So like terms that we have written down are those that have x in it. 4x, minus x, 2 by 3x. Now what about the rest here? Now here I have minus 3y, then I have 4 by 5y, and again I have y by itself. Now these three are also like terms because they have the coefficient y. They have the letter y which is similar to all. So we have one more set there, that is minus 3y, 4 by 5y and y. So there are two sets of like terms here. Next question. Here also, now let's look carefully for the letters. Here I have x, y. Let's look for x, y again. Now here also I have x, y, though the order is different. Order is different, but I still have one x and one y. So these two are like terms. Now this is y, z. It can't come along with this. This is also y, z. Now this is z, y or y, z. It can be in any order as long as the letters are the same. Then we have yx. So we can take all the xy's together. This is one term with xy. Then again I have one xy. Then here also I have another xy. So these are all one set of like terms. So we have written that down. So that's 2 by 3xy minus 4yx and the last one yx. So the order can be different, doesn't matter, as long as there is one x and one y. Okay, now the next set of like terms are these with yz. See, there's a yz here, there's a yz here, and there's a zy. Again, the letters are the same, order is different. So another set of like terms, 2yz minus 2 by 3yz, zy by 3. Question 3. Now here we have minus ab square. So 1a and 2 b's. Okay. This is not the same because here there are 2 b's and 2 a's. We are looking out for 1a and 2 b's. So can you see here 1a and 2 b's? Order is different. So these two are like terms. Okay, 1a and 2 b's. Here also 1a and 2 b's. Let's see if there are any more 1a. No, the next one is not the same. The last one, yes, 1a and 2 b's, b square. So these three are like terms. So we have written that down. So ab square minus ab square, 7b square a, 2ab square. So like I said, even if the order is different, it's okay as long as the variables are correct. So there is 1a here and 2b's just like the other two terms. Now let's look at this. This is b square, a square. There are two of each. Here also we have minus 3a square, b square. So these two are like terms. They have the same number of letters and the variables there, literals. So let's write that down. So b square, a square minus 3a square, b square. Question 4. Now here let's look out and see. So here we have ax. Let's see if there are any more ax. Now here we have xa. That's the same as ax because there's 1a, 1x. Now the last one also we have ax, 1a and 1x. So these three are one set of like terms. So what do we have? 5ax, 7xa and 2ax by 3. Then the last one here we have by. Here also we have by. So those are like terms. So what do we have there? Minus 5by and by by 7. So these are like terms. Question 3. State whether true or false. So let's look at the statements. First one, 16 is a constant and y is a variable. That's true, isn't it? But 16y is a variable which is also true, isn't it? Only if a number by itself, if a number is there by itself, it's a constant, and a letter by itself is a variable. But when you have a number and a letter, it is a variable. So this statement is true. So let's write that down, true. Next one, 5x has two terms, 5 and x. No, this statement is false. The reason is 5x is one term. This is one term. Only if it is separated by a plus or a minus sign, then you can say it is two terms. But here 5x means 5 into x, which is a single term. Third one, the expression 5 plus x. Yes, now there are two terms. There are two terms, so it should be separated by a plus or a minus sign. Only then can you separate them into different terms. So this statement is true. The expression 2x square plus x is a trinomial. What's the meaning of a trinomial? It should have three terms. A statement that has three terms, an expression that has three terms is called a trinomial. But this one, there are only two terms. 2x square is one term and x is another term. They are separated by the plus sign. So there are two terms. So this statement is false. Next one, ax square plus bx plus c is a trinomial. Trinomial means it should have three terms. And this is true. Ax square is one term, bx is another term, c is another term. So this statement is true. Question 6. A into ab is a binomial. Bi means two terms. Binomial means two terms, but this is a multiplication sign. Only if it is a plus or a minus sign can you say that there are two terms. Now 8 into ab can be written as 8ab, which becomes a single term. So this statement is false because the statement says A into AB is a binomial. So this statement is false. Question 7. 8 plus AB is a binomial. Binomial means two terms, and this statement is true because there is a plus sign. So this is 1 plus 1, two terms, and so this statement is true. Question 8. The whole thing given to us is a polynomial. Now, when do we call an expression a polynomial? When there are one or more unlike terms, and they're all unlike. As you can see, x cubed, xy, x, they're all unlike terms. So when an expression has one or more unlike terms, it is called a polynomial. So this statement is true. Next one. The given expression is a multinomial. So what is a multinomial? That is an expression which has two or more than two terms. So as you can see, there are many terms, 1, 2, 3, 4 terms. So it is a multinomial also. So this statement is also true. Question 10. The coefficient of x in 5x is 5x. Now, what is the meaning of a coefficient? Now, there are factors here. Now, 5x means 5 into x. So, if I say what is the coefficient of 5, the remaining factor, which is x, will be the coefficient of 5. So, what is the coefficient of x? We leave out x and say the remaining, which is 5. So the coefficient of x in 5x is actually only 5, whereas this statement tells us that it is 5x itself, which is false. The coefficient is what you leave out and the remaining factors. Leave out what is asked. So we are leaving out x, and whatever is left, that is the coefficient. So this statement here is false. Question 11. The coefficient of AB in minus AB is minus 1. So when the letters are by themselves, that means there is one of it, isn't it? So this is minus 1 AB. So when we are talking about coefficient of AB, we leave out AB and write whatever is left. So whatever is left is minus 1. So this statement is true. Question 12. The coefficient of y in minus 3xy. So leave out y because they've told us about coefficient of y. So what is left is minus 3x. But what does this statement say? The statement says the coefficient of y in minus 3xy is minus 3. No, that's false because it is minus 3x. So this statement is false. Question 4. State the number of terms in each of the following expressions. So the first expression given to us is 2a minus b. So look out for the plus or minus signs. So this is a minus sign. That means it is separating two other terms. So here we have one term 2a and here we have another term. So the question is state the number of terms. So there are two terms here. Next one, 3 into x plus a by 2. Look out only for plus and minus signs. There's only one plus sign. If there is only one plus sign, there are two terms because 3 into x can be written as 3x. So that becomes one term. So that's one term. This is another term. So there are two terms. Next one, 3x minus x by p. So there is one minus sign which is separating the two. So 1, 2. Two terms. Next one, a divided by p into a divided by x into b becomes one term. The whole thing becomes one term. And there is only one plus sign, so there is one more term. So this is one term, a divided by x into p. This whole thing is one term. This is another term, so that is two terms. You should only look out for plus and minus signs. The other signs cannot separate terms. Next one, 3x divided by 2. So this is one term. Then we have a plus sign. Then we have y, which is another term. We have one more plus sign and we have another term. So 1, 2, 3. Now we have three terms. Next one, xy divided by 2. Now xy divided by 2, I can write it down like this. So in this case, it becomes just one term, isn't it? So the answer here is 1. Next one, here again look out only for the plus and minus signs. There's only one plus sign, that means there are two terms. So this is one term and this is one term. Y divided by A can be written as Y by A, which becomes one term. So one term here and one term here, there are only two terms. Next one, 2x plus Y plus 8 divided by Y. So this 8 divided by Y becomes one term. Y is another term. 2x is another term. So it makes it 3. Ninth one, 2 into A becomes 2A. That's one term. So we have plus. Then we have another term. Now 3 divided by B. This whole thing becomes one term. Then we have a plus sign. So 1, then we have 2, then we have 3. We have 3 terms. So there are 2 plus signs, so there are 3 terms. Next question, state whether true or false. Xy and minus yx are like terms. So here I have 1x and 1y. Here also I have 1x and 1y. So they are like terms. The order is different, but the variables are the same. So they are like terms. This statement is true. X square y, that means 2 of x and 1 of y. Now here there are 2 of y and 1 of x, and the statement says they are like terms, which is wrong. They are unlike terms. Next one, a and minus a are like terms, which is true. There is 1a here and there is 1a here. The sign doesn't matter. So this is true. Question 4, minus ba and 2ab are unlike terms according to the statement. Now there is 1a and 1b here. Here also there's 1a and 1b. So these are actually like terms. So this statement is false because the statement says that they are unlike terms. Next one, 5 and 5x are like terms, which is false because here there is an x and 5 is all by itself. There is no variable there. So this statement is also false. 3xy and 4xyz are unlike terms. Now there is 1x, 1y here. Here there is 1x, 1y and 1z. So they are not like terms. They are unlike terms. So this statement is true. Question 6. For each expression given below, state whether it's a monomial or a binomial or a trinomial. What is a monomial? If there is only one term, it's a monomial. If there are two terms, it's a binomial. If there are three terms, it's a trinomial. So let's look and see. Now this first expression, there's only one term, so it is a monomial. I'll just put the first letter, so you can write the whole word. It's a monomial. Next one, now if it is separated by a plus or a minus sign only, can you separate them into different terms? So here there is 1 plus 1. There are two terms, so it's a binomial. Next one, this is a division sign, so you cannot separate them into two terms. So this whole thing is just one single term. So this is a monomial. Minus a is by itself. There's only one term, so it's a monomial. Now here ax squared minus x plus 5. So there are two signs, minus and plus. It separated all the terms. So 1, 2, 3. There are three terms. It's a trinomial. Here we have minus 3bc plus d. So we have a plus sign here, an addition operation. So it has separated these two terms into two separate terms. So that is a binomial. Seventh one, 1 plus x plus y. So the addition sign has separated the terms. So 1, 2, 3. We have 3 terms. It's a trinomial. Eighth one, plus sign is there, but this is a division sign which cannot separate the two variables. So there is one term here and one term here. So there are 2 terms. So this is a binomial. Next one, we have a plus sign and a minus sign which has separated all the terms. So 1, 2, 3. We have 3 terms. So that is a trinomial. Question 7. Write down the coefficient of x in all these monomials. As you can see, they are all monomials. They're just single terms, one term alone. Now we have to write the coefficient of x means you leave out x and write the rest of it. Okay, so let's begin with the first one. Now if it is x by itself, that means it's 1x. So I'm going to leave out x, so what is left is 1. So here also I'm going to leave out x, so there's 1, so that's minus 1. Now here, leave out x, you have minus 3. In the fourth one, again, leave out x because we are asked to find the coefficient of only x. So leave out x and write the rest, minus 5a. In the fifth one, leave out x, 3 by 2y. In the sixth one, leave out x, a by y. So these are all the coefficients of x in the different monomials. Question 8. Write the coefficient of. So each question is different. Let's go through it carefully. First one, coefficient of x in minus 3xy square. So coefficient of x, that means leave out x and write the rest. So it's minus 3y square. Next one, again x in minus ax, leave out x and write the rest, minus a. Now y in this, leave out y and write the rest. So that's minus 1. Again y, so leave out y and write 2 by a. xy, this time it's xy. So leave out x and y. And what is left? Minus 2z. Next one, ax. We have ax, so leave out ax. We have minus y square left. Now x square y, so leave out x square y. So this is removed. What is left is minus 3a. Then we have xy square, leave out xy square. What is left is 5a. So this is how we write the coefficient. Now next one. Question 9. State the numerical coefficient of the following monomials. So again we have been given monomials as you can see. Now what is the meaning of numeral or numerical coefficient? From the word numeral, we are talking about numbers. So in all these monomials, we have to only pick out the number along with its sign. And that becomes the numeral coefficient. So in the first one, 5xy, take only the number. It is 5. In the second one, a, b, c, we don't have a number. That means it's understood there is 1. Next one, again, we have only 5. Take the number. Now in the next one, we have minus 2 by 1, which is equal to minus 2. Then here we have 2 by 3. The number is 2 by 3. Question 6. If we take out the numbers, we get minus 15 in the numerator. In the denominator, we have 2. So that becomes minus 15 by 2. Now here, minus 7x divided by y, if I have to write it as a fraction, what do I get? Minus 7x by y. Now let's write only the number. So it is minus 7. So the answer here is minus 7. Similarly, the next one, minus 3x, if I write it as a fraction, by 2y. So what will my number be? It will be minus 3 by 2. Question 10. Now here we've been asked to write the degree of each of the following polynomials. So we have different polynomials given. Now, if you look, there's only x here, isn't it? So these are polynomials with only one variable. There's only one variable x. So here, to find the degree, we have to look at the powers. So if you look at the first term x here, there's only 1. The power is 1. It's raised to 1. Whereas the second one, it's raised to 2. So when you have to find the degree of such polynomials where there's only one variable x, look for the highest power. So here it is 1, here it is 2. The highest power is 2. So this is called the degree of this polynomial. Now next one, here also, this is a polynomial with one variable. We have only x. So look for the highest power of x. So here it is 2. Here there's only 1. So the highest power is 2. So 2 is the degree of the polynomial. Next one, again we have only one variable x everywhere. Look for the highest power. 3, 8, 10. The highest power is 10. So 10 is the degree of this polynomial. Next one, here we have x with 20. So let's write down the highest power there, 20. Now next one, again we have in one variable we have x. Here it is 1, here it is 3. The highest power is 3. Then here we have a polynomial made of different variables. We have x and y. We have y here, again x and y. When you have such polynomials that are made up of various variables, you have to add up the powers. So here for the first term, 8x square y, x has 2 and y has 1. 2 plus 1, there are 3 here. So the power is 3. Here in the second term, the power is 2. In the third term, let me add up the powers. 2 plus 5 is 7. So we have to add up the powers when there are more than one variable there. So here the first one is 3, then 2, then 7. Which is the highest power? 7. So 7 is the degree of such a polynomial which has more than one variable. Now here again we have, this has only one. Here there are two variables. Here also there are two variables. So let's see the highest power. So here it is 3. Here we have to add up the powers. 2 plus 3 is 5. Here again we have to add up. This is 1. 1 plus 5 is 6. So the highest power is 6. Next one. Here also we should look for the highest power. The first one has 2. The second one has 3. The third term has two variables. We have to add it up. 2 plus 7 is 9. So which is the highest one? 9. So this is the degree of this polynomial. So with this, children, we come to the end of this exercise. Thank you, children.